Good afternoon, everyone. So thank you, Guy, for the introduction. So today I'm really excited to present to you a work in progress, Robinhood V4, that aims at scaling Robinhood for the future. So a while back, we received a few complaints that Robinhood was not scalable enough. Thomas presented you a few ways to improve that, among which upgrade to the latest version of Robinhood. Maybe if you have problem with the scalability of the scanner, use the latest scanner that we are currently developing, and also the JMalloc allocator is a nice improvement. But overall, there is still one bottleneck that this won't solve for you if it's the backend is actually the problem. So in V4, we decided that we wanted to switch from MariaDB backend to something that scaled much better. So we wondered a lot about which backend we should use. We considered several, and in the end, we focused on MongoDB. The thing is, we also want to be able to support multiple backends. So MongoDB is actually the target for V4, but it's not supposed to be the only backend that we support. So from there, I think it's interesting to present to you how this latest version will be architectured. So the idea of Robinhood remains the same. It's all about having data in a backend that's really easy to query and fast. So there is data that comes in and out. And since it was really hard to adapt Robinhood, because the backend was tightly coupled to the code base, we decided that we wanted to abstract this backend with a C API. And so on top of the C API, because the C API is still very low level, we have a Robinhood library that is a nicer interface for applications to plug in. And this library also includes generic implementation for the C API, so that backend, to support backend, you don't have to implement every part of the C API. You can actually rely on things that are already implemented in the Robinhood library. And yes, from there, it's really easy to just plug applications. The backend may change, but the application will remain the same. You won't have to implement them twice. Just a quick note on the fact that this is a work in progress, and currently I'm focusing on the RBH find command. So all of the rest, everything that's not in bright color is actually not implemented right now. I don't have an ETA for it either. So yeah, anyway. So the backend now is really isolated from the applications. It can either be MongoDB, as I said in the introduction, or MariaDB. If you want to go back on it's actually pretty useful if you want to switch from one backend to the other to be able to support MariaDB, or even something like Postgres. But as I said, the target is MongoDB, and right now it's MongoDB only. So it's easy for me to say that you will be able to switch from one backend to the other, but if we actually ever support only one backend, just having your dreams. So a good question to ask at that point would be, how hard is it to implement a backend? Well, this is actually a hard question to answer. This is quite subjective. So I hope I'm bringing some objective facts. Currently, the MongoDB backend is only 600 lines of code. It is still work in progress, but I don't expect it to go over the 1K lines of code. So I would say it's not that hard, especially considering that most of it is just boilerplate. But there is a twist. It's that the MongoDB C driver is actually really nice. It's actually really close to the C API that I built, so it's possible that using another C driver, this will not apply. So I don't want to lie to you. It looks like it should be easy. And now, good question to ask now is, how does V4 compare to V3 or regular flavors of find, considering I'll only focus on RBH find. So I ran a few tests on a Lustre file system of 400K entries. I didn't have the time to put in more entries. I only did the measures like 3 days ago. I used this single server with a collocated MDS, MGS, and OSS. and a client that's not on the same physical machine. So the results are actually great for Robinhood v4. We can see that GNU Find and LFS Find are actually comparable, except in the size. Maybe I should explain the graph. In Ordinate, you have the time to completion, and to run my test, I simply ran find, different flavors of find, with the command line options that you can see on the axis. So the first block of bar diagrams are without any options. The second one is with just dash name A star, and the last one is a dash size plus 512, because my file system entries were really small, so I didn't have anything over 1 kilobyte. We can see that in any cases, RBH Find v4 actually performs very well. This is a logarithmic scale, so it is actually always 10 times better than the best implementation currently. I think that's quite good. There are some peculiar measures because, for example, LFS Find is actually really small, really slow with the dash size option. I'm not sure why. Maybe someone here has an answer for me. I expected it to go a lot faster than this. Well, the important thing to remember is that RBH Find v4 is going to be very fast. But there is one case where RBH Find, even v4, is really slow. This is also true for any Robinhood command. Anytime you want to filter on a path, it actually incurs a POSIX traversal of the database, and this is really slow. I'll explain why in a moment. What's really important to remember is that this applies for both v4 and v3, so it's something that you might want to look out for. This is just a summary of all the, including the RBH Find v4 path. So yes, how come the POSIX traversal of a database is so slow? So in a MongoDB collection, documents are stored flat, and when you want to do a query on all of them, it's really easy, it's quite fast, you just query them all at a time, and it responds very fast. But when you want to apply the POSIX logic to this database, you have to distinguish first which document represents the directory and which one represents the files. And since those documents are not ordered, you have to have them point at other documents in the database. And you cannot ask all the entries. You cannot apply the POSIX logic to something that is stored flat. So let me just sort that out for you. And let me show you how Robinhood actually performs the POSIX traversal on such a database. So first, if you query the root of the file system, you have to fetch the first document of the database. Then you ask for the child entries of these documents. You remember which one of those documents are actually directories, and you can recurse on the POSIX file tree that you have in your database. So this is quite slow because, as you can see, even on a very small file system, if you have 5 levels of files and directories, you have to do 5 queries on the database. And that's without considering that maybe not all of those results fit in memory. So it's maybe more than just 5 requests, 5 queries. V4 is still a work in progress. There is still very much to do. So this is mainly what was in one of the previous slides. I still need a changelog reader. I can probably reuse a Robinhood v3's changelog reader. There is still a feature missing, the RBH report, that I feel is very important. A web interface, but as Thomas said, the web interface actually obstructs the backend, so possibly the web interface can be reused. And I also need a POSIX scanner. You might ask, why do I need a POSIX scanner? If I don't have a POSIX scanner, how did I do all my tests? Well, I actually have one right now, but it's in Python and it's not really efficient. But I am actually wondering whether or not I actually need a POSIX scanner, because a POSIX scanner would probably look like this, an RBH scan command that would scan the file system, pull out all the entries, format them in something that the Robinhood library understands, and pass it back to the pass it down to the database. But what I'm really interested in doing is maybe I could implement the file system as just another backend for Robinhood. So I would have to implement a C API and put the Robinhood library on top of it. But from there, it gets really easy to just pull the data out from the file system, and the application, in this case RBH Translate, would really be a simple one. It would just be, it would just query all the entries from the file system. It would already get them in the right format, and I would just need to pass it down to the next database without any processing. This is useful to scan a file system, but this is also useful to maybe switch technologies if I want to switch from a MariaDB backend to something else, especially, for example, to switch from Robinhood v3 to something else like Robinhood v4. So that's it. Yeah, still a last part. I still have one last question, is that do we still need a policy engine from there? Once Robinhood Find is fully implemented, that's something I forgot to mention, but I'm actually looking forward to implement Robinhood Find as a complete clone of GNU Find. That means all the features of Find would be in RBH Find. That means all the filters, all the capabilities of Find. And if I actually get that, we can start to wonder which part of the policy engine we already have from that. So for example, this is how in Robinhood you delete all the old files that you have on your file system. You actually have to write a bit of configuration for this. You have to specify what the purge policy is and what's the file class old means. For example, you can say that the file class old is just any file that has not been accessed for the last 30 days. And this actually could just very simply be a find command, something that would look like Robinhood find any file that's 30 days older exec here and delete this. That's, as I said, this is still a work in progress. There are cases that won't fit into this this particular view of mine, but hopefully a lot of the work will be done as soon as RBH Find is fully implemented. This is my conclusion. This is a recap of the main goals that I'm trying to achieve with this v4. Obviously, we want to switch from MariaDB database, but there are also points that I'd like to maybe improve or just make even better with this v4. I would like this release to be even more developer friendly. So with since the v4 is almost a complete rewrite, I have many opportunities to make this code base very developer friendly. The admin friendly part, by that I mean the fact that, for example, RBH Find will be just, it will be usable just as Find. So I expect that this is easier from an administrator standpoint. And the scalability comes from just switching backends. All right, I suppose I'm a bit early. Thank you. If you have any questions.
Hello. Yeah, I had two questions, but one was actually just a bit more about your choice for MongoDB as backend. I mean, could you just say a bit more about what it is that brings over MariaDB, and kind of how that how you get sort of some of the improvements, and is there like changes to the sort of the format of the database that come from that?
Okay. So yes, there is a lot of change in the format. Every file system entries is currently represented as a single document. And there is no direct mapping from the current format that we have on MariaDB to a MongoDB format. What MongoDB really brings is a scalability, because you can spawn several MongoDB databases and use the sharding capabilities of MongoDB. So we expect to scale based on that. What MongoDB actually brings to is the fact that well, it's quite fast in itself, and ultimately, I wanted to use. There are many databases that were a good fit for this, and I chose MongoDB mainly because I knew about it and I knew how to use it, and so this sped up the development process. But hopefully, there are other databases that get implemented later.
Thanks. The one other thing I was asking was about your comment on like the filter path thing, because that's always like, so are you envisaging sort of similar to like the Robinhood v3 case, where you kind of, to speed up those queries, you would do like make file classes, that kind of thing? Because I use those quite heavily at the moment. And is there anything also in these database backends that could be done to make those filter path kind of queries better?
No, there are two things that you can do. So yes, the goal is to implement Robinhood so that I have the same features in v4 that we already do have in v3. Something that MongoDB is actually bringing. I'm putting the path, the full path of the file in the document. So if you want, if you're not too bothered by making a mistake because the path is not updated, when you rename a directory, for example, the path of its child entries are not actually updated at the same time. But if you don't care about this, you can actually filter on this field, particular field, and so you can have the performance of a global query on a filter path.
That's great, thanks.
Another question?
I don't want to take over all the questions, but is there some reason that you're not just reusing the same REST API and all the other changelog scanner, all the stuff that's in v3?
Actually, no, I just haven't looked into it. My focus was really ABH-Find because I felt that it was a good building block to maybe then escalate to Robinhood. It's probable that the REST API and the web interface actually work with this design too. I don't know about the changelog reader. I haven't looked at it enough right now.
Next question. Okay, thank you, Quentin.
Thank you.